Hello everyone, welcome to my new video. My name is Zoran and I am Cloud Solutions Architect. In my previous two videos, I showed how to build the architecture for Hyper-RAG and MCP and how those two separate systems can work together under the same orchestrator and complement each other. Today I'm introducing another important part of that story, and that is Text-to-SQL. So why do we need it? Because Hyper-RAG by itself is not enough when we need accurate, calculated, up-to-date business numbers. When the answer has to come from structured data and from the actual current business state, working only with documents and retrieved context simply isn't enough. At that point, we need a system that knows how to query structured data, especially when that data lives in SQL databases. In this case, Text-to-SQL is not just another nice add-on. It is a necessary part of the solution when we want precise, data-grounded business answers. In this video, I'll show you exactly what that looks like in practice. First, I'll briefly explain the concept. Then we'll look at the architecture and the infrastructure. And after that, I'll walk you through the full processing flow in a user interface I built specifically for this demo. So let's get started. Before we move into the implementation, let me briefly explain what Text-to-SQL actually is and what role AI plays in it. At the simplest level, Text-to-SQL means that a user asks a business question in plain language, and the AI model, together with the surrounding system, turns that question into an SQL query against structured data. The user doesn't need to know the database schema, table names, or how to write SQL. They just ask the question the way they would ask an analyst or someone on the business team. That is where AI comes in. Its job is to understand the meaning of the question, help generate the right SQL query, and then turn the returned results into a clear business answer. But there is one very important point here. AI is not supposed to invent numbers, guess results, or pretend to be a calculator. Accurate business values must come from real data and from the executed SQL query. AI is not the source of truth. It is the intelligent layer that helps the user reach the right answer from structured data using natural language. And that is exactly why this approach matters for business process automation. It allows people to ask questions in plain language, while the system using AI and structured data access returns precise, calculated, and up-to-date business results. And now that we have that basic idea in place, let's talk about how this differs from a Hyper-RAG system and why the two actually work so well together. For Text-to-SQL to work reliably, the data need to be prepared in advance. The system should not run queries directly against raw, messy data. There needs to be a prepared data layer, organized, cleaned, standardized, and exposed in a form that is ready for querying. In that sense, there is a clear similarity to the Hyper-RAG approach. Just as Hyper-RAG depends on knowledge being prepared in advance for strong retrieval and grounding, Text-to-SQL also depends on data being prepared in advance for reliable querying. And that is exactly why Microsoft Fabric Data Factory is such a great service for this role. Now we come to an important question. How is Text-to-SQL different from Hyper-RAG? At the simplest level, these two systems solve different kinds of problems. Hyper-RAG is excellent when the answer needs to come from documents, procedures, policies, technical documentation, contracts, any larger body of textual knowledge. But when we need accurate business numbers, totals, order counts, customer rankings, or any value that must be calculated from structured data, Hyper-RAG is not enough. That is where Text-to-SQL becomes necessary. And this leads to the most important point. In real business systems, these two approaches are not competing. They complement each other. One works with documents and unstructured knowledge. The other works with structured data and databases. When they operate together under the same orchestrator, the result is a much stronger and more complete business system. One provides context, the other provides exact values. And when you combine them, you get answers that are both meaningful and accurate. In this video, the focus is on Text-to-SQL, but it naturally belongs inside the same broader architecture where AI orchestrates multiple specialized capabilities. Now that we have briefly established the concept, let's look at how this solution is organized in the actual project. I'll start in VS Code because that is the easiest place to see the structure. At the top we have the root project folder, text-to-SQL-demo. The most important area is the apps directory. Right away you can see that this was not built as one giant block of code. It is split into clearly separated parts: Web UI, API Gateway, Orchestrator, Ingestion Worker, and SQL Execution Service. Even from the folder structure alone, you can see that the architecture is cleanly separated by responsibility. The key parts of this project were moved through a DevOps process into the Azure environment. Web UI in static web app, API Gateway, Orchestrator, Ingestion Worker, and SQL Execution Service into Container App on Azure. So the code we are looking at here is the development foundation, and the corresponding services were then deployed into Azure. Now that we have looked at the project structure, let's look at the cloud side as well. Here we move into the Azure environment. I'm not going to go through every single resource. The goal is to show that the architecture we saw in code also has a real cloud foundation. We have storage account, Azure SQL, container apps, container registry, and all the supporting resources needed for a production-ready solution. And because the data layer is especially important for this demo, right after this we move into Microsoft Fabric Data Factory, where the analytical side of the solution is implemented. In this project I use the Microsoft Fabric Data Factory workspace as the main working area. Inside it we have both a warehouse and a lakehouse, but the main focus is on the warehouse. There I use a clear medallion structure: bronze, silver, and gold layers. This warehouse receives data from two separate source systems. One pipeline is connected to our Azure SQL database, and the other is connected to Azure Blob Storage with CSV files. The same approach can be extended to other enterprise data sources, such as CRM platforms, ERP systems, or other structured and file-based sources. This allows data from different systems to enter the same Fabric environment, where it is organized through processing layers. The bronze layer serves as the raw intake zone. The silver layer is used for cleansing and structuring the data. And the gold layer represents the business-ready layer used for analytics and querying. With this approach, we bring data from different sources into a unified model and prepare it for downstream processing, analytics, and business scenarios. This is very important. The system does not work directly against raw data. It works against a prepared and controlled business layer. And that is exactly why Microsoft Fabric Data Factory matters in this solution. Now that we have looked at the development structure, the Azure environment, and the Microsoft Fabric Data Factory data layer, let's connect everything through the workflow diagram. This diagram shows the full process from the moment a user asks a question all the way to the final answer. Everything starts in the user interface. The question moves through the API gateway to the orchestrator. This is where the most important processing happens. The orchestrator understands the question, prepares the right context for the model, and guides the entire flow. Next, the AI model helps turn that question into the appropriate SQL query. That query is executed against the prepared analytical layer, the controlled business-ready data in the gold layer. Once the results come back, the orchestrator sends those results, together with the original question and context, back to the model so it can produce the final business response. So there are two important model phases. One for generating the SQL query, and another for turning the returned data into the final answer. The model is not inventing numbers. The system reaches the real data first. And now, let me show you the complete process in this user interface step by step. This interface is not the final user-facing product. I built it specifically to make the full processing flow visible for this video. To demonstrate that, I prepared 3 different business questions. First, show sales summary. The final answer gives a quick business overview, number of records, total revenue, total orders, and top region. Now let me briefly show how the system got there. The request is first interpreted by the orchestrator. That interpretation is visible in the interaction summary. Then the system prepares the context for the model, generates the SQL query, validates it, and executes it against the gold layer. The returned business data is shown in both summary form and detailed raw form. After that, the system sends the execution results back to the model so it can generate the final business response. And finally, the trace, freshness, and source panels show how the request was processed, how current the data is, and which curated source was used. So this first example shows the standard flow for a general sales overview. Next, I'll ask show top customer. This time, the final answer is different. Instead of a general overview, it identifies the top customer, along with the region, revenue, and order count. That tells us the system understood this as a ranking request. The overall process is the same, but the analytical path is different. The orchestrator interprets the request differently. The generated SQL changes to a ranking pattern, and the returned data is now organized as ranked customer results instead of detailed sales rows. Those ranked results are then used to produce the final answer. So this second example shows how the system handles a ranked analytical request. For the third question, I'll ask show Europe Enterprise Server Sales Summary. The final answer now reflects a more targeted request. It summarizes a narrower set of business results for that specific enterprise-focused Europe view. So right away, we can see that this is a more focused question. Again, the overall process stays the same, but the interpretation and the query become more specific. The orchestrator recognizes that this request needs a narrower analytical path. The generated SQL includes filtering logic, and the returned data is a more targeted subset of the overall sales data. That filtered result is then used to produce the final business response. So this third example shows how the system handles a more specific business request by narrowing the query and returning a more focused answer. What these 3 examples show is that this is not just a chat interface giving generic answers. The system can handle different kinds of business questions, prepare the right query, retrieve the right data from the curated gold layer, and produce a fully grounded response. The real value is not only the final answer, it is the full controlled process behind it. And that brings us to the end of this demo. What I wanted to show in this video was how Text-to-SQL can become a serious part of a broader architecture for business process automation. We saw that AI is not used to guess results. Its role is to understand the question, help form the right query, and turn real data into a clear business response. This approach requires more than just a model. It requires prepared data, a controlled analytical layer, a clear processing flow, and an orchestrator that manages everything. In the previous videos, I showed Hyper-RAG and MCP. In this video, I showed Text-to-SQL, and together these approaches form a much stronger and much more useful AI system for real business environments. Thank you for watching, and I'll see you in the next video.